The problem is to find the angle theta when the block released from the top of the sphere leave the surface of the sphere, assuming there is no friction. Now let us imagine a situation as in figure 2, when the block is making an angle theta, that is the center of the block to the center of the sphere, the line joining them is making an angle theta with the vertical. The projection of r on the vertical line will be r cos theta. So the height, the vertical height that is descended by the block, if it is h, then we can see that h is equal to radius of the sphere minus r cosine theta. Now we can equate the loss of potential energy equal to the gain in kinetic energy. So we can write a half mv square equal to m into g into h, where v is the velocity at this point of the block, and this is equal to m into g into r minus r cosine theta. So we can cancel m from both sides of the equation, and we get v square equal to 2 times g r minus r cosine theta. Now let us call this equation 1. Now let us find the forces that are acting on the block at this instant of time. There are 3 forces. The first force is the component of the weight of the block, which is acting towards the center of the sphere. So the weight of the block is m times g, and because this angle is theta, so the component of the weight will be mg cosine theta. This is the first force. The second force is the centrifugal force acting on the sphere, acting on the block. If v is the velocity of the block at this point, so that would be mv square divided by r. And the third force is the normal reaction Fn, which acts outwardly Now we can write an equation for the forces. The normal reaction will be equal to the difference of the 2 forces, one due to the weight of the block, the second one due to the centrifugal force. The block will leave the surface of the sphere when Fn is equal to 0. So this gives us mg cosine theta equal to mv square divide r. So we can cancel m from both sides, and we can use the expression for v from the equation 1. So that gives us twice g into r minus r cosine theta. So divide by r. So we can cancel g from both sides of the equation, and this gives us r cosine theta equal to twice r minus twice r cosine theta. So this gives us 3r cosine theta equal to twice r. This gives us cosine theta equal to 2 by 3, which gives us theta is equal to arc cosine 2 by 3. That is the answer. Thank you for watching. If you have any queries, you can contact me. My email address is